Greetings, everyone. So, today is something different. I started this project yesterday, and in 1 hour, did quite a bit. So, today I started to, work some more with it, and I got into the mood of going live. And what it is, it's a 1/12 scale microscope, and I'm just winging it, just putting together. It's going to be for 3D printing, filament printer, white plastic and black plastic. So I'm just, like I said, I'm winging it. I'm putting it together, and I don't know how it's going to end up looking. Like if it's going to be looking good or terrible. But I am trying to do it so it's printable, probably in different pieces and sections. And so I'm trying different things at the same time. So this might be DioWarriors' first 1/12 scale official 1/12 scale prop. So with that said, I'm going to switch over. I'm going to begin sharing the screen. I also got some music played in the background. I'm trying not to let it get too loud because I don't want it to, some sort of flag on YouTube or something like that. So I'm trying to keep it below my microphone's setting. Let's see, go window. So this is what I've gotten done thus far. The base and the inner piece I did in 1 hour's worth yesterday. So including the clips. So yesterday, so today I started working on this top part, the eyepiece assembly, and of course the eyepiece. And let's see. I think it might be a good idea I get something to drink while I do this for my voice, So be right back. Be right back. Be right back. Maybe I should do banner. Yeah. Be right back. Okay, sorry about that. I'm going to get something to drink. So, okay, I guess I can put my phone over here. Get over there. So, okay, where did I leave off? So let's see. So this microscope in 1/12 scale. I'm designing it in parts, and I'm trying to keep what's going to be in black plastic, in the darker gray on the screen. Now, the thing is that this is 1/12 scale, and it's not going to be done in resin. So there's a few issues, with filament printers, and so that's what I'm trying to overcome, those little issues. Basically, the resolution is not going to be as it is going to be good. Okay, it's not going to be as good as a resin, of course, but it will be very good. The thing, though, is that the plastic needs a bit of surface to stick on the build plate. So I designed every piece so there's, one side is going to be down, touching the build plate. So the ugly side. And everything else is going to be, it's going to be nice. So I have to design with one side facing down, and then that means, I'm fighting gravity as I go up. So I'm keeping that in mind as I do all of this. So what I'm doing here is, I don't want to insert a component. I want to make this. So what I'm doing here, I'm just working on the top eyepiece sections. And I'm not sure yet if this is going to be as a separate part. See, let me explain. What I can do with SolidWorks is I can design, like, for example, these two pieces here as two separate parts. So I could design this, for example, to be printed on one machine, this to be printed on a separate machine. But if I wanted to, I can fuse these two pieces together into one part, so they get, printed on the same machine as one piece. There's some advantages in doing that, and one of the advantage is that I could design something, in one direction, very easy, and then put it to an odd angle, attach it in an odd angle that would otherwise be a little bit more of a headache to design. Let's see. I got the windows open. I think someone's cooking something outside. I can smell it. Might be like a barbecue, so I'm smelling the smoke. So anyway, let me see. I'm kind of winging this at the moment because I'm not sure of the thickness that I need right here. So for this, I'm just going to just drag it into this place here, but I'm just eyeballing right there. Yeah, so I'm trying to keep my options open, where I'm trying to keep it where I could either design, for example, this section as two separate pieces or fuse them together in one. And I'm thinking right now, I'm leaning. Let's see. The thing is that if I print it as one piece of plastic, it'll be in white. So I have to go back in and paint it. And I'm not sure if I want to do that at the moment. It will paint well the way I'm going to do it, yes. But I'm not quite sure if... You see, there's give and takes. One, if which direction is this piece going to be printed, you know? I'm printing it down this way, so that means it's going to be, you know, being printed up. If I print it as one piece, it's going to have this eyepiece connected to it. So that means the printer is going to be going in this direction, so all this will be at a certain angle. It won't print badly until it gets to here. That might be a little bit of a challenge as an overhang. I'm doing things at 45 degrees, so basically this would be flat there, and that would be a little bit of an overhang issue. There are ways to get around some of that, so that's one thing I have to consider. Now, if I print this as a separate piece, then I can print this standing up. That won't have a problem. Then I would have to attach it. So that's what I'm thinking about right now. So let me see about attaching this, making a piece to attach this. It'll be simply like a glued-on piece. So if that's the case, let me switch to the eyepiece. Go to here and make an outline. So at DioWarriors, we don't do 1/12 scale items, but we want to. Or should I say, I want to. And right now, I am loaded with orders. I'm trying to get them out. And in fact, when this print finishes, I'm going to have to start another one. So 1/12 scale will take longer because, you know, obviously it's a bit bigger. So that becomes a thing of, you know, if I'm doing, you know, a 1/12 piece, maybe it might take twice as long, you know, than another piece that's going to be smaller and taking less. So, you know, there's the give and take. But I do want to do 1/12 props and see how that goes. You know, especially the laboratory stuff, high tech, you know, computers, things like that, since we have the props already for them. So let me increase this to 0.25 offset. Let me select the offset. Let's go base geometry. Okay. And let me just, for my own purposes, put a center line piece right there. Now I'm just going to copy this. Copy. I'm going to keep this in the sketch for future reference. So let me save this. I think I can go ahead and close this window. So let me go to this part, which is right there. And go sketch. Let me do a center line. Paste, and then just connect to the center line. Then let me do another offset. To do 1 millimeter, but 1.25 will look okay when it prints. I don't want to do that. Okay, select chain. And that might be good enough to do 1. Let's just see how that goes. Okay, so let me make a little extrusion. Let's extrude this 1.25. One direction, and the other direction, let's see if I say to the surface, which surface would be best? This one? Yeah, let's try that. Okay. So let me save this. Let me go back to this assembly. And let me undo the mates for this. Delete, yes. Delete, yes. So let me drag this out. Let's go mate. That surface, 0.25. This surface, yeah, up here. And this concentric to there. And of course, this concentric to here. Okay. Then I can now take this piece, make it mated concentric to there. And I was thinking of making this rotatable, but I'm thinking for this design, I'm not. I'm just going to have it fixed. So let's see how this works first before going too elaborate. Or should I say before going more elaborate. So I'm going to say parallel. So I want this with a separation of 0.25 here. Okay. Save. Now, one thing I will do is let me so I want to keep the, I don't know what you call this of a micro, this platform. I don't know what you call this part, but I'm thinking maybe I need to lower it just a little bit because I still have the lenses to put in. It just might be too close. I also want to add a little bit of thickness to the bottom part here while I have this on my mind. So I'll take this, add 0.5 millimeter more, so make it 2 millimeters. Okay, save this now. And let's see. Yes. So this is how it's looking for the moment. So all this is like sculpting on a piece of stone in a certain way, where you have a big block and you're just chiseling away at different parts to kind of make the shape the way you want. I tend to find that a little bit easier of an approach rather than trying to design the part, beautifully at first. So so my approach tends to be just throw something down first and then kind of shape it and make it the way you want it. So let me open this other file here, access this. Now this one will be printed like this. Now this piece here, I may move it to a separate, or actually I may put a little piece of plastic on the back part here to kind of uh, deal with any overhangs, which we'll have. This is an overhang right here, and this is an overhang right there, and but it should be thin enough that once it's printed, maybe I can go in with an X-Acto knife and just kind of chip away, or it might look okay and just leave it there. Maybe I could do something else, like some little piece connected to it with a knob or switch to kind of hide the support. So anyway, what I'm going to do here is lower this platform. Now I did this entire section on the plane, and I think all I have to do is just change the height of this plane. Fingers crossed, because I don't want to have to redo anything. So I kind of go one. No. That's up there, huh? This plane, sorry. I'm glad I noticed that before editing. Okay, so let's make this 9 millimeters down there and see. Save. Yes. Uh, oops. Wasn't expecting that I have to make adjustments to this. I thought it was going to be a nice clean move. What's the height? 5. Yeah, that looks good. So let me just move this down. Oh, you know what? Control Z. I got pieces here. Yeah, this is what I need to do. Bother. I gotta move this down. Okay. Much better. But still, it's a bother. Yeah. Okay. What's it doing here now? Okay. Hopefully, I can move on. Let's take a look at how it looks. Okay. Kind of thinking it still needs to go down further. I'm just thinking. Yeah, it is going to have to go down further. So, okay, let me just do that right now. Maybe move it down 2 millimeters more. It's a bit further, but I guess I should just do that now and kind of get it over with. I'm just going to make this 0.5. Okay. That. Okay. Sorry, there's a lot of times where it's just nothing but little fixes here, little fixes there. Bought some Coke, but it feels flat in a can. So anyway, I may have to play around with these little triangular support pieces here. Come on. Oh. Wrong mode. I need to go into sketch mode. Okay, better. Oh, look at that. Yeah, I definitely have to. 4.5. This should be 5. Okay, this has me annoyed. I'm going to force it to the dimensions that I want. So it is 5. Okay, never mind. Okay. Let's go back to the first then and alter this. Yeah, it looks big. 6. I want 5. Okay. Much better. Let's see. Save this. Okay, so now let's take a look at how the whole thing looks. Okay. It's gonna be kind of tight, but oh well. Save. So anyway, as I work with doing this in 1/12 scale, I am having similar thoughts to when I worked on some other parts at 1/12 scale, thinking that 1/12 scale is not a bad scale. It's, yeah, you got more details, but it's not a bad scale to work with. But in doing it for 3D printing in particular, it gets me to feel, to think this is more like designing a model, because you got smaller parts, more details. Because it has more details, it's more of a challenge on printing. So might as well print in more parts, and then just glue and assemble the parts after. So that becomes more and more like a model kit, and it's a little bit like my own philosophy when it comes to doing these. Let's just make it 1 millimeter. These props. We're not designing for the child, really. We're designing it more for the adult. And there's some challenges in that. The adult is going to be willing to suspend disbelief, but only to a certain point, after which disbelief becomes a bit too incredible, too incredible to accept. So, unlike a child be more willing to suspend a greater aspect of disbelief. Okay, so now what I'm thinking about is how and where I'm going to do the, I guess I put right smack in the middle, huh? The part for the lenses. Let's see, if I put something in the middle, if I make it 5 millimeter, that's 5 millimeter radius. So this should be 10. Yeah, 5 millimeter radius. So looking on the caliper, taking a figure. Actually, it should be less. Let's make it 6 millimeter diameter. So that's 3 millimeter radius. Okay. Now this is just going to be a marker for me right now. Let's just say 5 millimeters. This is just a marker. Okay. I just want to see how deep this will go before it starts looking awful. Okay, not too bad. We have some room to play with. Okay. So this is, a simple microscope. I was thinking though of doing it where you could have a third eyepiece on top for mounting a camera or something like that. One of those where you could have additional optronics connected to it. Or, as you're looking into it, another person can come and take a look at another eyepiece, to look down and see. Or, or hook up a camera to that third eyepiece for viewing on the big screen or some other device. Now, of course, I haven't given too much thought yet about knobs and adjustment controls. So, for example, the eyepiece here will have to have a knob for adjusting the height. Same thing for adjusting the Z on the platform. So I'm thinking of, see, it's going to be printed on the flap right there. So I'm thinking of actually on the body of making a raised piece and having a knob on that, or perhaps mounted down here somewhere. Um, yeah, I'm going to have to also sculpt out some aesthetically pleasing front faces for this, because it's kind of boxy. So okay, the next part, what I'm going to do here is make this into a donut, essentially, with the intent that I would have to print the lenses as a separate piece and then apply it. So, okay, right there. So let's go to this marker. Let's edit this marker. So I'm going to work with doing offset. 0. Because this is a circle, 0.125 will be the offset I will be doing here. And I'm going to do another offset of about 1 millimeter. So, as you guys already know, we like doing the sci-fi theme at DioWarriors. That's our big thing. And I like, in particular, I like doing the laboratory type stuff, computers and other devices. So if I click this, it's going to work, and then I just have to go in and change the height of this. Let's say 1.25. Let's say 1, actually. We go a little bit less. 0.5. Why? Because I can do this. I just thought of it. Since this is going to be printed like that, okay, I have this material right there that I can actually carve into. So I can cut away this here, make it a little bit deeper. Features, extruded cut. So what's good? Let's say 1.5 would be good. So in other words, I'm going to be printing 1.5 height before I actually start printing the actual details. Okay, so let me do this now. Let me save this first. I already had an issue this morning where I guess there was an error on the network, some little hiccup. And SolidWorks later told me it couldn't save a particular file that I was working on. I hadn't saved it already. I haven't saved it. I just started it, and I was putting things together, and then it told me it could not save. So I left, came back, and I was thinking I'm going to go ahead and see if I can just make a small little piece on a different file, save that, and see if saving works. And if it does work, then I'll just cut and paste everything over to the new file. So I went ahead and did that test. And then when I went to save it, I was using the same file name I was intending to use. And the thing told me that the file already exists. And guess what? There's a thumbnail showing the file that I wanted to save was already saved. It was asking me if I wanted to overwrite. And so, of course, I say no. And I was thinking, okay, well, let me just go ahead and clear the cache and all that stuff from software. So I closed the program down, started it up again, and I went to look for the file. Doesn't exist. So I had to redo that. Let's see. So let me go new. Let me go and do, say, top. Let's design this from bottom to top. So I'm going to do sketch. We said it was 5 millimeters. No, we said it was 6, right? Yeah. So but 3. So since I'm entering the number here on the screen, I can just say the diameter. But if I enter it on the side over here, I have to enter the radius. Okay, so features, extrude. So let's go and do 2 millimeter height. And we were saying 1.5, right? And then it was half a millimeter. So let's just say 2 millimeters. Okay, so here now comes the real work on the part. First, I'm going to make a little flaring or a little flange or something like that. So I'm going to work right there. So it's going to be here. And the flange is going to be about, or the flaring, however you want to say, 0.5. Just a little bit of a lip. I want this to go 0.75. I'm going to be fighting for as much space as possible at this point. There, then I'm going to do a center line. I'm not done with this at all, so yeah, so center line. Go on. This is going to be quite an interesting thing I'm going to be doing. 3 lenses, okay? Each one being a cylinder. But I'm not going to do it extremely detailed because, you know, what's the detail of these lenses? You know, they have a little bit of a grip, but then the main thing about them is what? They have, you know, little markings for, you know, basically painted on printed markings. You know, like the resolution, things like that. You know, the magnification, things like that. But they don't really have like, you know, grips for the fingers to grab on and twist and other little things like that. They don't really have too much detail. They're basically cylinders. So I'm going to try to do the same simple approach here. And I'm thinking, instead of having the cylinders at different angles, because then I would have to print the thing. I could always print it at a different angle too. I could always do this, so it prints at about, let's say, 45 degrees. But to keep things simple, I'm just going to have it as a simple set of cylinders, one stacked upon the other, going straight up. So, okay, let's try this for the moment. I could have just made this into a regular circle, yeah. I should try that. I was thinking of something else. Let me cancel this. So as I talk with you guys, I'm thinking different approaches. Like I said, you know, when I'm winging something, there's going to be a lot of changes, you know. So I said it was 1.5. Let's do an offset 1.5. And not 1.5, sorry, 0.5. That's going to be an overhang. And so then let's say we want this inner circle to be construction line. Then we want the height. We were saying 0.75. 0.75. Okay. So then let's go sketch. Sketch. Center line. Okay. Just trying to think what would be a good. Yes. I'm going to make a little triangle piece here. So the lenses are going to be what? Maybe what prints really well? If I say 2mm here. Okay, so let's increase this. This is the base part. Well, let's just leave it like this. So the lenses, let's say, are 2mm. That's going to be quite a bit of a challenge. 1.25. That's 2.5. Okay, so let's say 2.5. That may be doable here. Yeah, this is going to be a challenge for the printer. Better if it was resin for this. Okay, so let's try this. Let's accept it. Let's say we want to do a circular sketch pattern, a circular array, and then just specify 3. Now we got 3 equal distances there. Now I'm going to raise this up. So if I say 5mm, okay, just something to work with. I come back here. Now I want to add like little details, little grips. So I go sketch. This, I go circle. I haven't looked at comments yet, so if anyone has left a comment, I apologize for not getting to the comments quickly. Let me do it right now. Comments. Okay. And let me go back. Let's see. Now I'm going to do an offset 0.5. Yeah, 0.5 is okay. I'm going to make this into a construction piece, and then I'm going to make an array of these. Also 3. Then I'm going to trim off these overlaps. Extrude this. Uh, 0.75. Now I'm going to do something first before I may have to move things around. So let me just go ahead and suppress this. Let me do a fillet of 0.25. Okay. Now, of course, I can always make the parts super detailed, and if I'm doing it for resin, I would do that. But I want to make this more friendly for regular filament printers. So I'm going to have this go down 0.5. Nope. Unsuppress. Let me see if my experiment is going to work. .5 chamfer. It may not work. 0.25. Make it smaller. Let's see, man, why not? Is it this part that's not making it work? Could be. Let's just say 0.5 and see how that works if I do the chamfer now. Okay, now I'm going to just see I want to change the view to the top. Now I'm just going to do different heights. So sketch. And I just drop it down 5 millimeters. Features. Cut. Huh. So I said, so this was like 5, right? Okay. Let's just drop it down, what, 2? Maybe 3. Oh, too much. 2.5. Okay. And this one, let's drop it down. Let's say 2. Sketch, sketch. Yeah, maybe I will do this for resin in this part. You see, things like this make me want to do injection molding for this because I can do a lot. I could do the same amount of resolution that you'll see in a resin print. And with injection molding, that resolution will still be there. And just that it'll be stronger than resin. It'll be plastic. Of course, some people consider plastic as a form of resin as well. But, for simplicity's sake, you know what I mean. So, say 2. Okay, let's say 1.5. So then let's do another chamfer. And let's do fillet. Now, because this is going to be for filament printer, I'm not going to go and do further details. Now, if this was for injection molding, then I'll come back to it, and yes, I will do higher details on all of this. And, I'm perfectly capable of doing all of those very impressive details that you'll never see unless you take a magnifying glass. And for example, if I was doing this for injection molding, I would be putting the circle part where the lenses would be. So 0.5. Computer, I don't like this song.
Okay.
Then I do a pattern. Oh, I go features and extrude cut of something like 0.25. Well, actually, I would do less than that. I would go 0.15. And I would do a little chamfer and then a little dome for the lens. If this was being done for resin, really. So let me go there and go sketch. I want sketch. Sorry, circle. I momentarily distracted myself. What did I say this was? 0.5. So it's 1. Okay, and then keeps the setting. Okay. And then do it here again. I feel like actually doing it more detailed. So I might just in case. It will print, okay? Even with the high details, it will print. Will it be recognizable to the naked eye? No. But it will print. What I intend to do is print it in plastic that I can vapor smooth, and so that means a lot of the smaller details will get washed away as well, unless I go very lightly with the vapor. But it is fun to add even more details to it. I mean, it is fun. I'll make a point into that in just a moment. But yeah, so like, and I'm willing to. I know how the results will be already. Okay, so this is not going to like, blow my mind or anything like that, because I know the results. As I've done testings. I've done testings for this. Let me go ahead and do the dome. Where's that? What? It's not a sketch. Yeah, features, dome. Yeah, look at that. It's a 10 millimeter. So 0.15. Yeah, look how thin that will be, how small that will be. I could say it's, you can imagine that. So I could say an elliptical dome, but this would be better like this. And let me do the same thing. Select that. Go features, dome, 1.5. Okay. Select this surface. Go insert, features, dome. And let's go another fillet. So if I were to do this for resin, then I would do something much smaller, like 0.13. Resin printers won't have a problem printing that. And save. Ooh. Let's say lenses. Say lens A, 1-1. Oh. Yeah. Facebook, Okay, let me see. Let's see if there's any. Okay, no messages on Facebook. Okay. Okay, so let's see. Okay, so let me take this surface there. Go insert, mirror. Not mirror, sorry. Mentally distracted. So 1.5. This direction. Okay. So let me Go there, go sketch, sketch, sketch. Okay. And then let's do an offset. Uh, 0.5. Again, a resin printer won't have any problems with this. I go features, extruded cut. So let's make a little extruded cut that's going to be recognizable to the human eye, which would be 0.25. Okay, the human eye will see this easily, including with a filament printer. Let's do the same thing here. Select this surface there. That's the reason why I left a little gap. I go insert, reference geometry, plane. Go flip. And then I select sketch, sketch. Okay. The print just finished. I'm going to have to start another print. Let's see. Tomorrow is mailbox run, so I'll be going to the USPS. So I'm trying to get some more orders out for tomorrow. Reverse. We go features, extruded cut. Should have kept the previous settings, yes. Okay, now this one's going to be a little bit of a challenge because it's so close to the bottom. This surface, go insert, reference geometry plane. Flip. Oh, hey, look. Okay. Good, good, good. Just made it. So then here, then we go sketch, sketch. Then I go offset, reverse, features, extruded cut. All the way down. How about that? Okay, so save this. So the anatomy of the lenses area is that I guess at the factory when they're putting these things together, they can simply screw open the top lens part, put the lenses inside there and all that, and close it up. Now I'm going to do little fillets. .125. Looks like it's going to rain. It's very dark out there. I don't want to do it there. Like that there, like this here, like that there. Maybe I'll make the this opening a little bit less. And I do, yeah, I may do that, maybe a little bit less. I'm kind of thinking, well, maybe not. Maybe I'll just leave it like that. Yeah, I think I'll make it a little bit less plain and cut, right? So then this could be half of that. So would it be a problem for the printer? Half of this. I need to switch gears soon because I need to add more 125 more filament to the printers, but I also want to take the opportunity to protect the filament from moisture. Now with my technique here, let me deal with this. So now I can put it to there. It will still be noticeable, and maybe actually a little bit more pleasing. I'm just trying to see. Yeah, I'll leave it. I'll leave it alone. Yeah, so this would be okay. Ah, look at that. Okay, this will be okay. And let's make it a little bit more smooth. Okay. Yeah, this should be okay. So save. Now let's go to the other part right here. And let's add a fillet. I don't know if the T is silent. Add a fillet, add a fillet. Fillet, I don't know. 0.25. What's that? That song about tomatoes. You say tomato, uh, I say tomato, you say tomato, 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 tomato. How does it go? I don't remember the rest. It's an old song. Okay. So that should print nicely like that too. Now let's do another fillet. I'll say fillet with a strong T until I find out otherwise. So if I say 0.5, okay, save, and then I come to the piece, and I say fillet again, 0.5. Save this. So we're getting close to finishing up. Let's see how it looks. See, one thing that's fun as a designer when it comes to doing these larger scale props is that we can show off our skills with details. That's probably one main reason that 1/6 scale is fun to work with, is that you can show off as a designer. I personally like 1/18 scale much more, okay? And you can do a lot more with it, I think. But in the limited size, when I say limited size, is storage, being able to display props, vehicles in 1/6 scale. You end up using more space for that. So you end up running out of space quickly. And so, it's more limiting. The bigger the prop, more space goes for it. So you limit what you can do with it. You can only go so far designing and building a diorama for a 6-inch scale figure. 1/18, you can get you know quite a bit of stuff inside of a small space. But 6-inch scale figure. So I do find it more limiting as a collector. Now, as a designer, no, I don't. Okay, so let's insert the lens. I want it upside down. So let's go move component, rotate. You see, if I were to make the lens at an angle, then I do have to have more of a I would say more room just to do the angle part. Make this concentric to here. Then I'm going to select, pull this out. I'm going to say I want there with a little space, 0.25. Okay, I could do a little bit more. I could make the thing a little bit uh, more by increasing this space. I think I'll do that. So save this. Switch gears to this here. Going to yeah, I need to print some protection for so I have these Rubbermaid boxes. What I need to do is make like a little spool holder inside that can rotate easily, and something on the bottom to kind of, like a A-frame is going to come out. And I would like to do that on one of these small little printers here rather than a bigger one. So I'm going to try that right after this. Maybe it's worth another video. Because it has other options for people who are not doing props. Generic 3D printers people. So that was one. Let's say two. Let's see how it looks with 2mm. Okay. Save. I just thought of something too in terms of detail. Okay, so let's take a look. Say yes. Not so bad. Let's do this. Let's right here. Let's say sketch. Let's make a little circle. Let's do it actually right here. Come on, 45 degrees. Right there. I'm going to trim this. That way I have an endpoint. I'm going to get rid of this circle, make it into a construction circle. I'm going to do a little circle here at 0.5, so it's only 5mm. I can treat it as a circle. I don't have to do anything more. I'm going to select it. I would say circular sketch pattern. How many do we want? 50? Let's do less. 40. Let's do 30. Okay. 30 looks good. Let's go features. And let's go up to surface. Let's just do it to here. Yeah. And let's do zero point 0.25. 0.125 would be better. I have that. Just do this over and over. Well, this, let's try this. canceled. There was a problem somewhere. So let's do it again. Let's go fillet. .125. I guess I'll just have to do it manually. Deal with any unseen problems. Yeah, this will look nice with the resin. This will come out with a filament printer. Oh, get rid of that one. Notice the machine is taking a little bit of slowdown as it refreshes. Two more. This one and this one. Okay. Select it. Before anything, save it. Look at that. I just want to see. No. I don't think this part is really important. Okay, so let's see how this looks. Maybe it's too many. Maybe it needs to be less. So save it again. And let's switch it to this. Yes. Yeah, maybe it's too many. Looks too much like a gear. But let's see. I usually don't have to go back in and alter. So let's see if it'll be easy. Say 30 right there. Can I simply select it and say something like, say, 25? Would that be better? Let's take a look. because I removed 5 of it. It doesn't find 5, so we're just going to say okay, and then just go say yes. Okay. I think it would have automatically removed them. Okay, so let's try this. Let's take a look at that. So yes. So let's go back to this piece and begin making things nicer. So right here. Actually, sketch. Actually, I don't want to do that there. Let's go back to this. So this one, edit. Okay. So I got 2. Right here, just make a line going all the way. Trim. Okay. Same thing with this one. Two. So trim, 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 trim. Okay. This music started good. Computer, skip. Okay, so let's see. Save this. Let's go to the main assembly and take a look. Okay. So the logic is when this moves down, it's going to prevent the platform from impacting the light source by these guardrails, something like that, by these parts. So that's the logic. Let's see. Now, do I want? I'm going to close off. So we'll switch. Sketch. Okay, sketch this. There. Mirror. Oh, thought it would have done it automatically, but it didn't. Mirror. Okay, there it goes. And then features. We can make this about 1 millimeter thick. Choose that direction. Okay. Do platforms have details on the surface? I don't know. Let's see. Sketch, sketch. Offset. That's 2 millimeters. 1. 0.75. That's good. Yeah, I'm going to have to switch gears. I'm thinking more and more. It's important because what happens is that moisture can affect the quality of the plastic and make it misbehave. So when you put it to the printer, it might be troublesome. It might be too. It may have expanded because of the water, become brittle, all sorts of stuff like that. Let's make this a little bit less. Let's make this well, I don't want to say 0.5, but yeah, let's try 0.5. Okay, and let's just go ahead and make this mirror to the other side. And features, extruded cut. And make undercut of 0.5. Details there. So let's do this. Let's go here. Let's go to that. Let's go sketch, sketch. And yeah, let's just do a bunch of lines. This to here. Okay. Let's kind of tricky. I want to, so let's make it 2. So let's from the corner. I just want to put details. That's all. In the corner, let's say this is 2. Okay, there. Mirror entities. Which one? Well, we want to mirror this. Okay, and let's do. Let's do a circle. 1.98. Yeah, let's just say 2. Okay. Let's do again offset there, and let's do another mirror right in the middle. And same mirror. Boom. Features. So extruded cut. Okay, that's yeah, okay, right here. Sketch, sketch. Let's do hexagon. About 1.15. Okay. And mirror this. Features, extruded cut. I want to do something here. Let's go. I want to see it. Select this surface. Okay. Go to sketch. Sketch. Well, how come I can't see it? Okay. 2. And the same thing, just 2. Features. Extrude this. Yeah, about 5 millimeters more. Okay, that's fine. And then do a chamfer. 0.5 is good. This and this. Zero point 0.25. I feel like designing a laser weapon, some sort of handheld device. I'm going to start doing some research on how they should look. Okay, then I'm going to go select this. Come on, fillet. Yeah, 0.1 to 5 is okay. Now let's see. Another fillet right here. Of 0.5, 0.25. Okay, a little bit more friendly for printing. Oh yeah, one detail I wanted to add before moving on. I'm not gonna do a square. Come on. Rectangle. Come on. Show me the middle. There it goes. Okay. Getting a little bit tired, but I'm going to have to switch gears. Keep saying that, but I'm going to have to do it. Yeah, okay, that's good. Trim. Okay, I'm going to do offset, I believe. 0.125, bidirectional, base geometry, select chain. Maybe this is not right. Yeah, it's a little bit off. Let me do this actually. Let me do this at another time. I'm not quite in the mood on doing this particular piece. So with that said, let me just fillet this right here. 0.5. You can get a lot of details. You can really go overboard sometimes. Look at that little light bulb. Okay, so let me try a rounded corner. 1 millimeter. See how that looks. Let's increase it. 2. Yeah, 2 looks okay. And then let's do a fillet of 0.25 on top. And 0.5 on the bottom. Oh, come on. It's coming along. It's coming along. Save. And let's do right there. Sketch along this plane right here. Let's just do a simple reinforcement of this. Let's go all the way down. Let's go a little bit in. Little features. Yeah, you can tell I'm a little bit tired right now. I probably should take a break, and then I need to start the other thing. Let's just let's try 1 millimeter and then just go mid plane like that. And I'll think, see, this will be the support. If it prints like this will be the support. And but to help hide the support, I'm thinking of putting some other little piece here, maybe a little box. It's going to be kind of small to go in and clip. Even though it's at 1 millimeter, it wouldn't be too bad. But if I got a bunch of these to do, you know, yeah, it can take time. Okay, so I'm going to just leave it here at the moment and begin to kind of wrap up for today. Save this. So let's take a look at everything. Yes. Got to work on the clips a bit, make the clips look a little bit better. Oh, look at all that. Yeah, because I messed around with the clip. Look at that. Not a problem. I can say, again, a concentric mate here. No, not to that. No, not the face. Concentric mate to this. To here. How come it didn't go all the way? Probably interfering with another. That's a tangent for me. Concentric. There it goes. Same thing with this one. Make this to there. Concentric. Okay. So I'll work on these clips later. So it all starts with the eyepiece today. Okay. That's how it's coming about right now. I don't know. I'm kind of not liking the way this thing looks. Looks too much like a deer. I may just leave it out. We'll see. We'll see. Maybe I'll print twice. One with, one without, and see how it looks. Okay, I think I'm going to call it for today. It's like it's missing something. Maybe I need to put something here. It's kind of missing something. I mean, they are simple. If you really think about it, they're not really very stylish. Some of them look advanced and everything, but they're functional. Basically, everything is functional on them. They're not really going for the fashion look. Not like a car or something like that. I don't even need to make these cylinders. I can make this part here further straight. So we'll see how that goes. I gotta decide where I'm going to put the knobs. Maybe just slap one on the right side. Maybe it should be around about here. Well, no. Well, yeah. A little bit off center because, simple gear workings on the inside. Yeah. Knobs. I gotta get careful because I think when it comes to 3D printing in 1/6 scale, it's easy to get carried away with the details. So if you're targeting a filament printer, those details can exist, but it's no guarantee that the printer will be able to print them. It will try. You may not see any error. The details technically will be there, but the printer is just simply not capable of actually rendering those details. But it will try to print them, and technically they will be there, just not visible. A number of reasons, plastics fusing together, just getting too small. So the thing is that it's easy to get carried away and load details. And then when you go to print it, well, you still have to print a certain side down, deal with the limitations of the way a filament printer does it. Resin prints can do higher detail. You do have a limitation because one side has to be in contact with the build plate. Usually it's upside down. So with a resin print, usually you end up having a lot of support material that you have to clip off afterwards. Of course, the support material itself is high resolution, so you can clip them off and then sand the resin so it's smoother, therefore hiding a lot of the support bumps that are left over. So that's one thing there to consider. But if you're doing this like I am for filament printer and not a resin printer, it's easy to have scope creep, and design it so you end up having too much resolution that's not going to be visible, and it's just going to make the parts a little bit more of a headache. For example, I'm thinking about the knobs. Okay, it would be nice to have the knobs with little finger grips rather than just simply a circle cylinder. Now, The filament printers can do those finger grips really nice, but the larger the better. It might do okay. I have to see with this scale because it's not 1/18 scale. And but the thing is that now if I want to do it in black plastic, for example, it'll be a separate piece. So it'll be a small little bitty thing that I'm printing separately. Or if it's together with another larger part, let's say, for example, if it's the eyepiece, okay? If it's the eyepiece, and this is something I might try to do, then I may have the knob further down, like around this area. And therefore I would have a little piece of plastic cut into this box part. Okay, cut into here. So that way, when I print it, it prints as one piece. The thing is that if the eyepiece has the knob too far down, then I'm going to have to print it with supports and then cut away the support. Or if I keep it as one and no supports, but keep it as one piece, basically making the bottom part thicker. In other words, the base of it acting as the support. Then when it goes into this part, this boxy part, I'm going to have to cut away on the inside a bit more. So I might end up having basically a donut, a hole going all the way through. So you get to see, there are pros and cons. If I have it if I have the knob as part of this piece, it might be easier. I would just have to go back and paint it black. But when the thing prints, it'll be printing this direction up. So just like the light source, I'll have to do some sort of triangle piece for the support. Unless I want to have the support going all the way down. And the thing is that if I have this support going all the way down, I would have to clip it. Well, if I have a triangle piece like this, I would have to clip it anyway. So use more material going all the way down or less material as a triangle. So, there's ways to cover that up too. Can add greebles, can add something that the knob is next to. So it actually, the support part actually connects to that. But it looks like it doesn't, that kind of thing. So anyway, that's how this is looking so far. There's a few other things I will do for laboratory that I'm thinking of. The scale prop that I have in 1/18, that will be another nice piece in 1/6. I would like to do the flasks for the laboratory stuff in 1/6 scale, 1/12 scale, sorry. And but I'm thinking maybe do traditional casting, only because it takes long to do the 3D prints, and what I'm thinking of is those floral arrangements that have like fake water. It's a type of acrylic resin. It's very, very clear. So I was thinking of making a mold for that and basically trying a solid, clear flask. So I was thinking of doing that. So lots of things to experiment and try. And although I do like the laboratory in 1/18 scale, I may have to put that off for an injection molding project, which is developing. So I may put that off for that. In the meantime, I can probably redo those laboratory flasks and stuff as a 1/12 scale, 6-inch scale laboratory prop and see how that goes. Providing if the stuff about doing molds would work. Might end up just setting the molds, and if you want to do your own, laboratory stuff, you just, pour it in and do the molds yourself. I mean, it's terminology. You make a negative mold to pour the resin in to make a mold. But people don't normally talk about a negative mold. They just talk about you make a mold you make a mold to pour in and make a mold. So it's both called a mold. So but I like to refer to it as a negative mold because it's a cavity, and then you just pour the other stuff on top. So anyway, so I may do something like that in silicon as a fun little side project. Make a mold, make silicon molds to do flask molds. Well, okay, this is good for now. I think what I'll do is I'll make a capture the screen and post this as a thumbnail. Well, folks, thanks for sticking with me this long. It's not a very exciting thing, but especially if you get to watch it. But I have a lot of fun with it, even though I'm tired. But so I'm going to have to switch gears, get the next print started, and then I got to do the spool holder. And I have a few ideas of how I'm going to do it. I have an older one that I did, and it kind of works. But if I can find it real fast, I have these spinner, these ball bearing pieces. If I can find that real fast, I have an older part that I did for a spool holder, and so I'll be printing this part again, but this time making an adapter for the spinner and having the spinner hooked up to something else, so that way it can turn with very little friction, and that's always a good thing. Okay, folks, thank you for watching, and I will catch y'all later. I should say stop screen. All right, please like and subscribe, and thanks. Catch y'all later.